basically we'll be understanding in this lecture what is a simulation, what are the advantages of simulation, what are the limitations of the simulation, and the next lecture will be starting with the numerical. So this is the basic lecture of understanding simulation. Normally 4 marks question on this topic is asked in your examination, right? So what is a simulation? Now, particularly, it is not a new, no, it is not a new technique. It is an old technique, and it has been used since very long by the designers and the analysts in the physical sciences, and it promises to become an important tool for tackling the complicated problems of the managerial decision making, right? So particularly if we see, no, these have been used by the designers and the analysts in the physical sciences since very long. But now what we are going to do is now particularly the people have identified its use as an important tool for tackling the complicated problems in for the managerial decision making, right? So few of the early examples where the this physical this simulation technique was used was like for aircrafts. No, aircrafts are designed, and no, they are directly not no, they are not been permitted directly to fly in the air. What they do is that they particularly test it in the windmills, and no, they particularly try to determine whether it is it is satisfying the principle of the aerodynamics, or all those particular researches are done. So what is this? This is nothing but the the aircraft is physically it is physically been tested in the form of the prototype in a wind tunnel to determine the its aerodynamics. So this has been done since very long, since you can see now when we started with the aeroplanes, and how this aerodynamic shapes and that has come up. So all this has been previously used, but now that people are harnessing, or people have also harnessed it to be an important tool for tackling the complicated problems where the complex managerial decision making is required, right? So when we move ahead, this it is an probably the first important if you see and understand the history. So the first important application of this technique of simulation was done by this two scientists, two researchers, that is John von Neumann and Stanislaw Ulam, and for studying the tedious behaviors of the neutrons. So what they were trying to do was they were trying to make a nuclear shielding, a nuclear shield, and they wanted to solve the problems of the nuclear shielding. So what they studied were they studied the tedious behavior of this neutron with the help of the simulation techniques, and that particularly why they went for the simulation technique, because the mathematical models or the mathematical analysis was very complex, right? So generally they found that up till their study, people were using the complex mathematical analysis, right? And no, these two scientists or researchers found that the math, instead of doing all this complex mathematical analysis, why not to go for why not to go for the simulation technique? And this happens to be the first important application that these two researchers did, and it was properly documented, right? So how we can define a simulation, or what is a simulation? In other words, it is just an imitation of a reality. So what the real problem environment is being what it is the real problem environment is being modeled, and all those real problems and all those particular things are modeled, and that happens to be a simulation. So it is not it is just a copying of your no, or it is just an imitation of the reality that we can do. Now it can be defined, if we try to define this simulation. The simulation is a representation of a reality, right? So it is a simulation, the representation of a reality through the use of model or other device which will react in the same manner as reality under a given set of conditions. So there are many problems. There are many problems in which we directly cannot experiment on a real, at a site level. So what we'll have to do is we'll have to go for something which represents a reality, and then we are going to do the, represent a reality. It can be, they are saying that for the representation of reality, the use of model is to be done. Now here when they say that the use of a model is done, so it can be a physical model, it can be a non-physical model, but here, yeah, use of model will be done, and the that particular model will reacting in the same manner as a reality under given set of condition. So this is how the simulation is defined. I'm repeating the statement. Simulation is a representation of a reality through the use of model or other device which will react in the same manner as a reality under given set of conditions. So there are many definitions of this simulation depending upon the understanding that the or understanding and the application that the researchers develop. So again, there is one more definition that had come that has been used. That is, the simulation is also defined as the use of system model that has designed characteristics of reality in order to produce essence of the actual operation, right? So one and no, the is, what we can say, the gist or the meaning of both of this definition remains same. It is just playing with the words and making it more technical. The second definition is more technical. So it is the use of the system model that has designed characteristics of reality in order to produce the same essence of the actual problem. So we are going to we are going to design that model in such a way that the design characteristics imitate imitate the essence of the actual operation in the reality, right? Now many times what will happen is that carrying out experiments on the physical models to determine that particular, carrying out experiments in on physical models in the laboratory to determine the behavior. So if you had visited the planetarium, which shows the simulation of the planet system, etc., the all these all uses the concept of simulation the reality in the physical form, right? So this is very important, right? So all this, if you had been to planetarium, what they would they show you how the solar system is working, how the solar system is working in the physical form, and that particularly is nothing but that is nothing but a that is nothing but an analog simulation, right? So here there can be, as earlier said, there can be the physical models or non-physical models that people have developed that will be helping them to imitate the um, reality. So this particular, if it is a physical model, so physical model, if there are physical models which are helping us to represent the reality, it is called as the analog simulation. There can be now, you shouldn't be restricting yourself to think that there will be only the what we can say, only the physical models that will be used, right? So no, there can be a non-physical model, so that will be used. For example, like computer programming and all those particular things can be used, which is called as a computer simulation. But here, if you are using any physical model, so it is called as an analog simulation, right? So now let's move ahead, right? So for complex and intricate problems of managerial decision making, right? So if I have to take any managerial decision problem, so this analog simulation is not practically possible. This is very, very important to understand. Okay, if I have to take any managerial decision, I can't go with the physical modeling. For example, if I have to for my site, I have 50 laborers working, 50 skilled laborers that are working, and I have to I have to increase the output at my particular site. So if I'm willing to find out what is the output if I employ like 100 skilled laborers instead of 50 as on present, so I won't be how the physical model will be helping me in that particular case. So therefore, this analog simulation, what we have seen, this analog simulation is of no use. there particularly what we'll have to do is we'll have to think of something different. Like, so managerial decision are something which are complex and intricate, right? So complex, I guess you understand, right? So it is no, complex is an opposite word to a simple, right? But what is an intricate? Intricate, if you try to search, no, if you have heard of this word and understood this word, intricate particular means that a problem which requires fine detail of finest amount of detailing is required in such type of problems. So these particular problems are no if are of sort of managerial decision making. Analog simulation is not helpful in that particular stage, right? So in such circumstances, the complex problem or that particular complex system is formulated into a mathematical model for which a computer program is developed, and the problem is solved on a high speed computer and is termed as a computer simulation or a system simulation, right? So particularly you have also, I'm very sure that you have heard of computer simulation or a system simulation. So only to make a difference, if there are physical models that you have, you know, constructed. For example, if you have constructed a prototype and then you are doing some experimentation on the prototype to, to imitate the reality. So that particular prototype happens to be a physical in a physical form. It is a physical model, and that particular simulation is called as a analog simulation. But if I have to know if there is if there is no possibility of making a physical model for a particular problem, then you can think of making or representing it into a mathematical format, and then the computer program to run this particular thing can be done. And on a high speed computer, you can do the simulation, and this is called as a computer simulation or a system simulation, right? So analog and system simulation, I'm hoping that you have understood the difference. And this is just the basic of the simulation. Let's understand what is the what are the advantages of simulation technique. Having thought about what is the basic of simulation, or what basically is the simulation and how the simulation is being defined and classified, let's move ahead and understand what are the advantages of the simulation technique, right? So managerial problems are complex to solve by mathematical programming or experimentation. Even if it is possible, it is too costly and risky. Simulation offers opportunity by allowing to do experimentation without interfering with the without interfering with the real system. Now, let's try to understand this with the help of an example. Suppose I'm designing a building, and I have to design it for a earthquake of magnitude like 10, which is very very high, or 9 or 10, which is very very high, and I have to find out how the my structure is behaving in this particular scenario, right? So I can't go on the site and no I can't go on site and create an entire structure and then check it to then check it to have an earthquake of like 9 or 10 Richter scale. So this is not possible. So experimentation, like no experimentation is not possible. Even if the experimentation is possible, I have the tools to shake that particular building to experience an earthquake of like 9 or 10 Richter scale. So that construction will be costly, and again it will be risky, right? So in such case, what I can do is that I can know the simulation will offer me an opportunity by allowing to do experimentation without interfering with the real system. So what I can do here is I can think of making a model, making a prototype of my structure, and then on particularly I can install that to my structure on a shaking platform in my lab, and then I can test what is the behavior of that particular structure for a Richter scale of 9 to 10. So what is happening is that I do not have to go on a site and create a what you can say multi-stored building, multi-storied building by investing multi-crore or multi-lakh of rupees, and then doing the experimentation, right? So that is very costly, and plus it is risky. What I can do is I can create a prototype by investing few thousand of rupees. I can purchase a machine which is of again few thousand of rupees, which will be which will be having a shaking platform, and which will be helping us to create the earthquake of 9 to 10 Richter scale, and then I can find out what is the effect of that, what is the effect of the earthquake on that structure. So right, so here I'm not interfering with the real system. Real system actually is not constructed. The real system, which is my actual structure at a site, is not constructed. Then too, I'm doing an experimentation regarding that particular build, right? So this simulation will be helping me. No, it will be helping me and providing me the opportunity by allowing to do an experimentation without interfering with the real system. This is very, very important. The no, if for example I have to no, if I have to go for, or let's see, the examples will be coming in some of the few points again. So simulation helps management to foresee the difficulties and the bottlenecks which may come up due to new alterations in the system. It eliminates the need of costly trial and error method that is normally being followed, right? So no, if there is a certain system, for example, if I'm into no, if I'm into a precast fabrication workshop, where the precast all this no, what we can say, let's think of not precast, it is prefabricated building workshop, where they have designing, or they are manufacturing the prefabricated building units. So they have thought of no, earlier, let's take an example that they have thought of they were doing curing, which was a normal curing, and now they are planning to go for installation of a machine which is doing a rapid curing in the form of steam curing, right? So now this is a new alteration that need to be done. But now particularly, if I have to foresee, the management has to foresee the difficulties or the bottlenecks which may come up due to the new alteration. For example, they have to see whether the space is okay or not, whether all this particular no, but there can be many bottlenecks and the difficulties which may come afterward, right? After installing that particular machine, right? So no, I do not have to install that particular machine right away. I can, this particular simulation will help that management to foresee the difficulties and bottlenecks. Now, what is the meaning of foresee? To foresee is particularly to identify the problems beforehand, right? So particularly will be visualizing that particular problem before its occurrence. So that is meaning of the foresee. So the management will be able to visualize the problems and understand the difficulties and the bottlenecks and identify them before the new alterations are made, and then they may be thinking of if that particular new alteration is to be done or not done, right? So now what will happen because of that? It will be eliminating the need of costly trial and error method, right? So if this particular simulation technique would have not been there, what would be the management do? They would be thinking, let's install this machine and then see what the problems arises, and if the problems are very, very difficult to handle with, we'll be removing that machine, and then we'll be doing we'll be doing or handling the system in the previous manner only. But now that particularly will be a costly affair, and it will be requiring more trial and error method. So this method happens to be costly, and the simulation will eliminate that particular need of doing costly trial and error combinations, right? So I'm hoping you have understood this. Simulation is free from complex mathematics and thus can be understood by operating personnel and non-technical managers also. Now, simulation has been done. It has to be brought. There are technical things into the simulation, but again, in many of the cases, the interfaces that are made to get an output for simulation are very, very simple, and that can be easily understood by then operating personnel, who can be a technical or non-technical, and even if even for the persons who are of the who are non-technical managers. For example, the MBA people who haven't done any, who do not have any technical knowledge, they have the managerial knowledge. So even for those particular people, the simulation can be helpful. Now, yeah, simulation will be involving the complex mathematics, but because of the interface of the simulation, what will happen is that uh, it can be easily understood by the operating personnel and the non-technical manager. So what the operating personnel has to do, operating personnel has to just provide an input, right? The non-technical manager has to just go for the analysis, but no, the complex and the mathematics is being handled by the that particular computer. So no, it is free from the complex mathematics for the person who is actually handling that particular system. Now, simulation models are flexible and can be modified to accommodate the changing environment of the real situation, right? So, particularly, this is very, very important. It is not a robust kind of model that we are going to develop. It is a flexible model, and if there are changes in the environment, in the sense environment not to be understood in a civil perspective. Environment is anything that is that is surrounding that particular environment is anything within that particular problem. So it can be any variable which is important, it can be any variable which is not important. Environment here is not to be taken as a synonym for paryavaran. It is not that, right? So environment is the it is the environment of your numerical or environment of your problem. So if the environment of your problem is changing, the changes can be made in your simulation model as well, and hence the simulation models are flexible and can be of great use for the modification according to the changing environment of that particular problem. And if there is a change in the real situation, there will be change in the problem environment, and that particular problem environment, change in the problem environment, can be taken care in your simulation model, because those are flexible model and not the robust model. So computer simulation can compress the performance of a system over several years and involve large calculation into a few minutes. So all those calculations, or all those all those simulation activities that would have required several years, several years of mathematical analysis and involving large calculations and large duration, can be just done in a few minutes with the help of the computer simulation. So even with the help of a computer simulation, you are going to reduce the time, and when the time is reduced, indirectly the cost is saved. So time is also one of the resource, and it is to be optimized, and the computer simulation can be helpful for all that particular thing, right? Simulation technique is easier to than no, it is easier to use than the mathematical models, and is considered quite superior to the mathematical analysis, right? So yeah, there will be some part of mathematical modeling or that particular thing here, but again, the the simulation technique, or the steps that we use in the simulation techniques, are superior to that of the mathematical analysis. It can be used for training and operating the managerial staff in the operation of complex plants. Training on simulated model before handling the real system. See, the simulation has got a very good benefit. It can be used for training the operating managerial staff in the operation of the complex plants before going on the real system. For example, now let's consider I have a I have an aeroplane, and it is manufactured by Boeing, and no, it is a very huge aeroplane, and it is no, the company has invested crore of rupees purchasing that, right? So if I have to train any pilot, why no? Is it okay to train the pilot on a multi-crore aeroplane that the company has manufactured or company has purchased? No. Why the company will be taking a risk to train the pilot on a such multi-crore no, particular purchase? What they will be doing is that they will be, if you know that there are the uh, simulated or what you can say, the simulation models that have been developed, or so simulation equipment that have been developed, that will be training that particular pilot. So the pilot has to just sit on, no, he'll be sitting like in the cockpit, he'll be given a simulated cockpit, and he'll be flying a plane, no, flying a plane in that particular cockpit without actually flying the plane, right? So he'll be doing all those operations of, all those operations that a normal pilot will be doing while sitting in a cockpit, in just a simulated way. So at that particular instance, the pilot can be trained for any unforeseen situation. For example, I can train a pilot on a simulation model for a incident like the birds have crashed into the aeroplane, or bird has crashed into the main engine of that particular aeroplane. At that particular instance, so how the plane will be behaving and how the pilot will be handling that particular plane. All those are the unforeseen situation. For example, if there is any fire incident that has occurred in any of the engine, so how that particular pilot will be responding to that particular, responding to the this unforeseen situation, and all this can be done on a simulated platform. Why I'll be employing, why I don't need to employ a fully operational plane which has been brought for multi crore of rupees, and no, I can't give training on that training to the pilot on that particular thing. So I'll be designing a simulated sort of operations, and that can be used, and it can be repeatedly used, right? Training is something that is to be repeated again and again, right? So that particular pilot can do that training, no, he can do that training and become a master in that particular operations with the help of the simulation model, right? So normally in the aeroplane industry or the air industry, this type of simulation is being done in many of the cases. In many of the situations, many of the situations, the operating or the managerial staff are given the training by using the simulation system. Now, now is the era of the virtual reality. Just a second. Hello. हो. हाँ सर, मी तुम्हाला एक कॉल बॅक करतो. आय मीन अ लेक्चर. आय बी कॉलिंग बॅक. ओके. Hello. Yeah. Let's begin. So, no. In many of the other industries also, now it is the era of the virtual reality, right? So many of the industries are training the people with the help of the virtual reality also, and the virtual reality also happens to be one of the extension of your simulation model. Even in the cases of the military trainings and firefighting situations, the simulation models, virtual reality is being used, and virtual reality is being used for training these persons. And it is not only just for the training of the person, it is also used for selection of the personnel, right? So if I have to check whether that personnel is good for this particular kind of operation or not, virtual reality is that particular platform which has been extensively used nowadays for these purpose, right? So it is also the extension of your simulation model only. So yeah, I was talking about this. Repeated use of a simulation model can be done, and this particular is no it is very beneficial because it is cost effective. So if the training is to be given, or any sort of thing, even any sort of operations, if I have to do some alterations plus some addition plus deletions in a particular model, so I'll have to repeat or I'll have to use the simulation model repetitively, and this is one of the advantages of your simulation model. It is valuable and convenient method to break down complex system into subsystems and study them individually or jointly. So this is one of the advantage, that any complex situation is broken down into an individual problem, and then it is individually solved or jointly solved. So this happens to be the philosophy of your simulation model, and it is also one of the advantages. So now, what are the limitations of your simulation model? now it's normally will have to the simulation model are not the replacement no are not the perfect replacement of the real life scenario, or those won't perfectly represent the real life, so they have certain limitations. So no simulation model fails to produce the optimum result, so that is one of the limitation why it is not giving us the optimum result, because when the model deals with the uncertainties, so when we are going to deal, no, it is not the exact imitation that will be that we will be able to do. There will be some certain uncertainties, and if there are if there are any uncertainties in our simulation model, the result of this simulation is only an it is only a reliable approximation. So the result that we are going to get is only a reliable approximation, and it is not the actual solution. It is an approximation, but a reliable approximation subject to the statistical error. So even your simulation model will have some statistical errors. So when there are unforeseen or there are uncertainties in your simulation model, you will be getting an answer in the form of a reliable approximation, right? And it will have some, it will be subject to some statistical errors, right? So quantification of the variables is a difficulty, right? So quantifying all variables that affect the system is impossible. You will have to consider certain variables only. We'll have to not consider certain variables, and that particularly will be increasing the uncertainties. So even you all will agree that quantification of all the variables is impossible. There are certain variables which are not in not in our hand, which can arise in a surprising manner, and because of that what will happen is that your system will be not a reliable system. Now, complex programming needs to handle a large number of variables and the interrelationships between them is observed. Variables may be too large for a computer to handle. Even this is the case. You'll have to do some complex programming because no large number of variables are there. Even amongst the variables, there will be some interrelationship, and it has been observed that the quantum of the variables or the number of the variables in certain cases can be it can be too large for the computer to handle. So this is also one of the one of the limitation that you can see. Hence in many of the cases you require supercomputer, right? So people go and develop the supercomputer just just because there are a lot of variables and the interrelationship that need to be handled, right? If you see the simulation, simulation is by no means a cheap method. In many of the cases, if we see, if we have seen that an example in which the simulation was, we were happy to say that the simulation is a cheap method, but in many of the situations, such as the corporate planning, the simulations is comparatively costlier and the time consuming. So in many of the cases, it can be expensive, and it may consume some time, and again the time is a resource. So this happens to be the limitations of your simulation technique. So if you see the applications of the simulation technique, the applications are very wide. I have given you some of the examples. In the field of the basic sciences, it has been used for finding out the area under the curve. It has been also used to estimate the value of pi, right? So in matrix inversion also, particularly, or to study the particle diffusion, the simulation technique has been used. In the industrial problems, it has been used for the shop floor management, design of the computer systems, the design of the queuing systems, inventory control, and lot of other problems. Even in the nuclear reactors, this particular simulation techniques have been used, right? So in business and economic problems, it has been used for predicting the customer behavior, price determination, economic forecasting can be done. It is being used for the portfolio selection and the capital budgeting as well, right? So even even the ministry peoples who are giving or forecasting the economical situation of a country use this kind of simulation model. In social problems, including the population growth, effect of environment on health and group behavior, the simulation model have been used. In biomedical systems, including the fluid balance, distribution of electrolyte in the human body and brain activities, simulation model has been used. It has been used in the design of the weapon system and the war strategies and even the tactics. In the study of the project involving the risky investment, the simulation model